Alright, gents, today we're going to look at difference of squares, and the sum and difference of cubes. I got the formulas up top ready to go. So remember when we are doing these problems and I say use the sum and difference of cubes, or and even generally I could just say factor, and then you guys would have to figure out which one to use. We're going to be using this set of formulas. And in the general sense, we want to get a squared or cubed plus or minus b squared or cubed. And remember, a slash b can be it could be a number, it could be a variable, or it could be both. And it can also be something of the form of like x, like let's say like x to the fifth. It could be x to an exponent. That's something that can be, or like 5x to an exponent. That's something that a and b can stand for. This can stand for pretty much anything. So let's keep that in mind when we do these problems. So I got one difference of squares, one sum of cubes, one difference. Oh wait, this is a difference. This is the sum of cubes, and then one challenge one down here that I'm gonna walk you guys through. So looking at the first one, we're gonna note first and foremost that we have a square, and that these two numbers are perfect squares. So it's a really good key in that we're going to be using the difference of squares, the top equation. So what we need to do is we need to write it as a squared minus b squared. So remember, or let's start with the easier part. Let's start with this number. How can we write 25 as something squared? Well, we just start by taking the square root of 25, and that's 5. So I know that 5 squared is equal to 25. I can do the same thing with the number 9, and we'll get the 3. So 3 squared x squared. So I want to rewrite all the numbers in terms of a square in this case. What we could do then is use the properties of exponents to rewrite this as 3x squared, the quantity, minus 5 squared. That property basically says if I have like a number, so like if I have, I don't know, 6v, and I square it, the squared goes to both of these. It goes to 6 squared, v squared, and then simplified. So essentially all we're doing is the backwards version of that. We're kind of undoing that. We're going from the more expanded version to the more simpler version down here. So now I have a squared and b squared. So our a is 3x. I don't know where the 3 just went. And our b is 5. So all we do is we plug it in to that formula. So 3x plus 5, 3x minus 5. And that is all that we have to do for now. Eventually what we're going to do, and actually I might as well just do it for, no, we won't get into that. So that's what we're going to do. Moving on to the difference of cubes. So we're going to use this bottom formula here. I want to write everything as cubes. Over here we wrote everything as squares. Now I want to rewrite everything in cubes. So 27, to find that, I'm going to take the cube root of 27. That's going to be 3. So I rewrite this as 3 cubed x cubed. And then the cube root of 64 is 4. So this is 4 cubed. And the list of all the cubes is on the PowerPoint. Or on the Google Slides, I should say, from last week in general. So that's already been posted. It'll be up there for you guys to reference, so no worries about that. So I'm going to do the same thing here and somewhat factor these out. So I'm going to be left with 3x quantity cubed minus 4 cubed. Now all I do is I find my a, which in that case is whatever's being cubed, so 3x, and my b is 4. So I take my a's and my b's after I found that, and I just plug it into this. That's as easy as it gets. So 3x minus 4, because we got the minus there, and then everything else is plus. A squared times AB plus b squared. So 3x squared plus a is 3x, b is 4, and then plus b squared, so 4 squared. I'm going to take another step just to rewrite everything in the most simple form. So now I'm going to have, this 2 is going to essentially get distributed, so I'm going to be left with a 9, because that's the same thing as saying 3 squared. Then an x squared. 3 times 4 is 12, so that's 12x. Then 4 squared is 16. Going to end that off with some parentheses, and we're good to go. So that's a completely... the completely... or the using the difference of cubes. That's how we're going to get that. And then lastly, we're going to have one with the sum of the cubes. So once again, I'm going to take the cube root of the number. So cube root of 8, cube root... Oops, that was ugly. Cube root of 216. Cube root of 8 is 2. Cube root of 216 is 6. So I can rewrite this as 2 cubed x cubed plus 6 cubed y cubed. So the only thing different here is that both of our terms have a variable. And that's cool. There's no big gripe. There's no super complex thing that we have to do with that. We're just going to have to deal with it. It's not that big of a deal. So once again, we're going to do this, use the property of exponents to kind of, in a sense, factor them out. So 2x cubed plus 6y cubed. Now I have my a and I have my b. So my a is 2x. My b is 6y. And I'm going to plug it in to the second formula. Oops. Plug it into the second formula, the sum of cubes, and then note that the subtraction sign is right there. So we're going to have a plus b to start out, so 2x plus 6y, then quantity 2x squared minus a b, so 6y, and then plus b squared, so that's 6y squared. Once again, I'm just going to rewrite this kind of the way I did this one, where I just expand it all out, do all the multiplication. So 2x plus 6y. And now we're going to have a 4x squared, because the 2 kind of gets distributed. 2 times 6 is 12. X and y can't be combined, but we can just write them being multiplied by one another. So 12xy. And then the same thing happens here. We're going to add 36y squared. Now, let's get... Oops. Shut up, Siri. Alright, so let's get on to our last and final one. This is the challenge one, and as you can see, nothing's being written in terms of cubes or squares. So what do? It's not that bad, I promise. So let's think about what some exponent rules are. So let's think about if I have x to the m to the n, what does this equal? Well, this just equals x to the m times n. Okay? It's much like the exponent rules where I have x to the m times x to the n. This is equal to the adding of the exponents. So like if I have x to the 5th plus or times x to the 4th, this is going to be x to the 9th. And we know that, or at least we should at this point. If I have exponents that go to other exponents, so I have x to the 5th to the 4th power, this is going to equal the multiplication of those variables. So this is going to be x times 20. This is a 4. So we're kind of going to use this fact to work backwards and do some division. So let's keep this up here. So I want to write to the 8th and to the 4th as either a square or a cube. And the way you can figure out which one you're going to use is if we just deal with the numbers first. So looking at the numbers, can we write them as squares or cubes, both of them? And you can see with 16 and 49, we can write them both as squares. So we could write 4 squared x to the 8th minus 7 squared y to the 4th. So I know to do this factoring out step that we've been doing here, here, and here, that we're going to need to rewrite x to the 8th y to the 4th as something squared. So let's think about our just up here. So I need this number here to be a squared. So that's going to have to leave us with the question of what is going to go in here. So what times 2 equals 8? That's 4. So I'm going to get 4 squared and then x to the 4th squared. So now I have the squared and the squared to deal with. I'm going to do the same thing off to the left. I have y squared squared. Because all I'm doing is I'm taking this variable and dividing it by 2. And whatever's left over gets brought down to the inside. Now what we could do is, like I said, we could do the quote-unquote factoring out step. Oops, excuse me. Missed that. So now I'm going to be left with 4 x to the 4th and that quantity squared minus 7 y squared quantity squared. So my a is 4x to the 4th. My b is 7y squared. And I have a difference of squares problem. I'm going to use our top formula. So a plus b, a minus b. So 4x to the 4th plus 7y squared, 4x to the x to the 4th minus 7y squared. Okay, so this is going to serve as a little mini review going forward. I know some of you guys were absent on either Friday or on, what day is today? Tuesday. So I go ahead and give this a watch, reference back to it if you need to. If not, have a good rest of your day.